Hello. So this is a recorded video that I will be posting to D2L for our Math 180 class. So this will take the place of Friday's lecture, and it is going to be on dividing polynomials, the remainder, and factor theorems. So let's get started. So first, what we're going to do is we're going to talk about long division. And to talk about long division, we're going to need to, in this section, we're going to discuss long division of polynomials. How can we divide polynomials through long division? Well, in order to understand how to do long division of polynomials, we have to understand how to do long division. So we're going to briefly recall, go all the way back to 3rd or 4th grade and do long division, right? So to do long division, we take the 26 and we're going to say, okay, we want to divide 3,983 by 26. Okay? And if we recall how to do long division, we take this 26 and we ask how many times can it go into this 39, right? Well, if you're thinking in your head, right, I say, okay, I know it goes in there at least once. Can it go in there twice? No, it cannot, right? So long division tells us I just put a 1 up here above the 9. Okay. And so what then I do is I say, okay, what is 1 times 26? Well, 1 times 6 is 26, right? And long division tells me to subtract that. That's what the division algorithm tells me. So I subtract 26 from 39. Well, 39 minus 26 is 13. But then I bring down the 8, right? And after I bring down that 8, I continue the pattern and I ask how many times can 26 go into 138? How many times can 26 go into 138? Well, it can go in there 5 times, okay? As 5 times 26 is equal to 130, okay? And so now I take 15 and I multiply it by 26, okay? So 15 times, actually, that's wrong, I apologize. I take this 5. I take this 5 and I multiply it by 26, and that gives me 130, okay? And so then I'm left with 8, and I bring down the 3, and then you keep on going. You ask how many times can 26 go into 83? Well, it can go in there 3 times, as 3 times 26 is equal to 78. And so I write the 3 up here, and I write my 78 down here. Subtract 5, right? And that's it. I am done, right? There's nothing else I can do. So my answer here of what is 3,983 divided by 26 is it is 153, but I have a remainder here. I have this 5 as a remainder. Well, because the 5 is a remainder, then it's 153 and 5 over 26. Okay? I'm usually not a fan of mixed numbers, but that's the rules here. And we'll discuss how these things work later on, right? So that is how we do long division. And what we'll find is that polynomial division is done exactly the same way. Alright, I gotta figure out how to move to the next slide with my pen. Give me a minute. I don't think I can do it there we go, I can just press enter. Okay, and so now the question is, how do we translate this into long division? Well, I want to divide x squared plus 10x plus 21 by x plus 3. So I take my x plus 3 and I say, okay, I want to divide by x squared plus 10x plus 21. So how do I do this? Well, you always start with your leading term, okay? You start with your leading term, and you start with the leading terms of both polynomials, okay? So I'm going to look at my x plus 3, and I'm going to say, okay, my leading term is x. And I'm going to look at x squared plus 10x plus 21. I'm going to say my leading term there is x squared. And then I ask, what is x squared divided by x? Well, that, of course, is x, and so I put an x above where the 10x is, because that's where it belongs. And so, just like with long division, I multiply that out. I ask, what is x times x plus 3? Well, say it along with me. X times x plus 3 is equal to x squared plus 3x. And so I write x squared plus 3x. Now notice, just like we did with our division of numbers, what we have to do is we have to subtract all this, okay? And what subtracting will do for us is it will change the sign. So this is no longer a plus, this now becomes a minus 3x. And so when it becomes a minus 3x, we do the math, we subtract everything. And what we get is that we have x squared minus x squared, well that cancels out. And then we have 10x minus 3x, well that is 7x. And then from there we can bring down the 21. Now, what you'll realize is that this x squared and this x canceled out, that'll always happen. It'll always cancel out. If it doesn't cancel out, you usually did something wrong there. Okay? And so what we'll see with this next step is that this 7x will disappear. This 7x will disappear. And if it didn't disappear, it means we did something wrong. So let's analyze this. This looks like a 4, but I promise this is a 21. I apologize for that. All right, so now we say, okay, what is 7x divided by x? That, of course, is 7. And so I put my plus 7 up here. And I say, okay, what is 7 times x plus 3? Well, that is, of course, 7x plus 21. But I subtract everything. So this plus becomes a minus. And so I have 7x minus 7x and 21 minus 21, which is 0. And so the answer to my question is x plus 7. That is what the answer to this division problem is. Okay. All right, so now let's kick it up a notch. Okay, so we have 3x minus 2 divided by, and this is written in a weird way, but you could rewrite this as in its decreasing order. So 6x cubed minus x squared minus x to the 5th plus 4. And so it's the same song and dance. All right, so what we do is we ask, okay, what is 6x squared divided by 3x? That, of course, is 2x. So we have a 2x on top of our negative 5x. And then we multiply and we distribute it. And so we say, okay, what is 2x times 3x minus 2? Well, that is 6x squared minus 4x. So we have 6 Making sure I did that right. Sorry, this was 6x cubed. I apologize, which makes this 2x squared, which makes this 6x cubed minus 4x squared. All right, we're good now. Okay, and so the reason why I knew that I made a mistake there was because I knew that when I put this here, that these wouldn't have canceled out. I know that because I flipped my signs that this 6x cubed had to cancel out. But with what I had over here originally, it wasn't going to cancel out. So that's how I knew I did something wrong. So that fact that I tell you that that leading term should always cancel, that could be of great use to you to help you solve these problems, just like it helped me there. Okay, so we cancel that out, and what are we left with? We're left with 3x squared, and we can move this down to get negative 5x. Okay, so we ask ourselves, okay, what is 3x squared divided by 3x? Of course, that is x. So this is going to just be an x. Meanwhile, over here was 2x squared. So 2x squared plus x. All right. And so what is x times 3x minus 2? Well, that is 3x squared minus 2x. But remember, we have to flip the sign of everything. So we change the signs. This cancels. And we're left with negative 3x. And we ask what's 3x times negative 3x divided by 3x. That, of course, is negative 1. Multiply that. We get 3x minus 2. Well, we got to bring down the 4. Three x minus 2. Flip the signs. Did I already flip the signs? Negative 3x. Negative 1. Okay, yeah. That's going to have to be that. Negative 1, yeah. And this is going to be a minus. I multiplied by negative 1 instead of positive 1, my fault. Cancel out, and so this is going to be a 2. Well, there's nothing else for us to bring down, so this has remainder 2. How do we deal with remainders when we in this situation? Well, what we say is that the answer to this now is 2x squared plus x minus 1, and our remainder in this case, how we write that is we say, okay, that is going to be plus 2 divided by the thing that we were dividing by originally, okay, this 3x minus 2. And so even though it looks weird, this is the answer to that question. So this is the answer to that question. So that's how it works. All right, let's do one more here before we figure out, okay, there has to be an easier way to do these, right? And indeed there is, but we have to do one more ugly one first. So we have 3x squared minus 2x, and we are dividing by 6x to the 4th plus 3 of 5x cubed. And we see that there's like no x squared. So when there's nothing there, you could just say plus 0x squared. Okay? Plus 3x minus 5. And the reason why is because you still want to preserve the space. You still need to know that there's an x squared there, because you could have a number up here that could give you x squared. Okay? So let's figure out how we do this. So we say, okay, what is 6x to the 4th divided by 3x squared? That is 2x squared. So as I said earlier, right, so this is going to be 2x x squared. Well, 2x squared times 3x minus 2x, that is going to be 6x to the fourth minus 4x cubed, but I flipped the sign of everything, and so that cancels out. Now I'm left with 9x cubed, okay? And I bring down my 0x squared. Let me just go ahead and do that. All right, so 9x cubed divided by 3x squared, that gives 3x. So I have a 3x right here. Distribute, that gives me 9x cubed minus 2, minus not 2, that's going to be a 6, minus 6x squared, change the sign of everything, 9x cubed cancels out, I'm left with positive 6x squared. So what is 6x squared divided by 3x squared? That is equal to 2. So I have a plus 2 times our factors here. So I'm going to have to bring down the plus 3x. All right, and so what we have is we have 2 times this, which is going to give us 6x squared minus 4x, but I have to flip over the signs, and that's going to give me, that cancels out, that's going to give me 7x. Yes. So that's going to be a 7x, and then I bring down the minus 5. Okay? Well, there's nothing else I can do here. I'm done. I'm stuck now. So the final answer to this question is actually, we say the answer to this is 2x squared plus 3x plus 2 plus a remainder is 7x minus 5, and that is divided by 3x squared minus 2x. So what I have in this box is our final answer to this question. Okay? So it's not pretty, but it's the answer. So there has to be a better way to do this, right? And indeed there is. It's called synthetic division. Okay? So we can use what's called synthetic division to divide polynomials if the divisor is of the form x minus c. So that's the biggest drawback of synthetic division, is that it has to be something linear. Okay? It has to be something like an x minus whatever. Okay? So you can't have squareds or anything like that when you're using synthetic division, like what we could in our previous slide. Here we were able to divide by something with a squared, but with synthetic division we can't do that. Okay, but it provides, it's much quicker. So notice with long division, you're doing this whole page, right? Well, with synthetic division, it's nice, it's clean, it's tight. All right, it's good. So let's figure out what's happening here. Okay, so we are taking x minus 3. So if our long division, we're taking x minus 3, and we do the whole algorithm, and eventually we get 53 down here, which is our remainder. Okay. However, with synthetic division, what we do is we say, okay, we are going to take that negative 3, and we're just going to make it a 3. So what you're doing is you're dividing by the 0. Okay. So the idea is x minus 3 equals 0. What does that imply? That means x is equal to 3. That's what you're dividing by there. Okay. You're dividing by x equals 3. Now, where's this 1, this 4, this negative 5, and this 5 comes from? So those are the coefficients of the polynomial here. So notice that x to the third has coefficient 1, 4x squared has coefficient 4, negative 5x has coefficient negative 5, and 5 is just 5, right? So that's where these come from. So now what you do is you take this first term and you just bring it down. So that's where the 1 comes from. You just take 1 and bring it down. Well, then you take this 3 and you multiply it by that 1 giving you 3. Well, then you add 4 plus 3, which gives you 7. But then once again, you take that 3 and it gets multiplied to that 7, getting 21. Well, negative 5 plus 21 is equal to 16. Multiply that 3 by 16 to get 48. 5 plus 48 is equal to 53. And so we have remainder 53. Okay, now this represented, right, this 1 plus this 1, 7, 16, 53, what that's represented by is that is represented by x squared, 1x squared rather, plus 7x plus 16 plus 53 over x minus 3. That is what this represents. Okay? So it's pretty straightforward. Okay? So how did I know that this was a 2? Well, because when you do synthetic division, you're always going to go 1 degree lower than what you were dividing by. Okay? So we were dividing by an x cubed, right? So when I divide by something that has just an x, the x minus 3, it's going to give me an x squared. Okay? So you're always going 1 degree lower with synthetic division. All right, so let's actually take this to its next level. So we have this, sorry, I'm trying to look at my notes at the same time. Yeah, so we have this x plus 2, right? We want to divide it by this 5x cubed plus 6x plus 8. All right, so how do we do this? Well, as I said earlier, right? We have x plus 2 equals 0. What does that imply? That implies x is equal to negative 2. So that's what we're going to divide by. Okay. Well, now what are the coefficients of this polynomial right here? Well, that is going to be first a 5, 5x cubed, but then we have a plus 0x squared. Then that is plus 6x, and then 8, right? So you still want to keep the places, okay? All right. So what we do is we move down our 5. Well, now we say, okay, what is 2 times 5? Negative 2 times 5. Well, that's negative 10. 0 plus negative 10 is negative 10. 2 times negative 10 is 20. 6 plus 20 is 26. 26 times negative 2 is going to be negative 52. And then negative 52 plus 8 is going to equal negative 44. Notice how that was so much more simpler than anything else, right? So our answer here would be 5x squared minus 10x plus 26 minus 44 over x plus 2. That's what that would be. Okay? All right, moving on. So let's consider the division algorithm when the divided f of x is divided by x minus c. In this case, the remainder must be a constant, because its degree is less than 1, the degree of x minus c, right? So that leads us to a theorem, okay? Theorem, if the polynomial f of x is divided by x minus c, then the remainder is f of c. So what this essentially is telling us is that in our previous slides, we had this negative 44. That negative 44 is our remainder, okay? That's what this theorem tells us, okay? So given this polynomial, use the remainder theorem to figure out what f of 2 is, okay? Well, to find out what f of 2 is, we have by the remainder, this thing is so hard to write with, I apologize, but by the remainder theorem, Okay. If f of x is divided by x minus 2, then the remainder, this is awful. I'm sorry, guys. Just the remainder is f of 2. Okay. So what do we do then? We say, okay, that's 2, and I write down the coefficients of this third degree polynomial, which is 1, -4, 5, and 3. I don't know what's going on with this thing. This is why technology sucks. All right, and so we have 1, 2 times 1 is 2, -4 times plus 2 is -2, 2 times -2 is -4, 5 plus -4 is 1, 2 times 1 is 2, which gives us 5, so the remainder is 5. Okay, that is what the theorem tells us. The remainder is 5. So pretty straightforward. Okay. So the factor theorem tells us to let f of x be a polynomial. So if f of c is equal to 0, right, then x minus c is a factor of f of x. So what that means is that if you have no remainder, okay, then x minus c is a factor of your polynomial. If s minus c is a factor of f of x, then f of c is equals 0. Okay, so that's a pretty nice theorem, right? Pretty much that means if you have no remainder, then this x minus c is a factor. Okay, so solve the equation, this equation, given that 3 is a 0 of this polynomial. Okay, so all we have to do there is use the synthetic division. All we have to do there is use synthetic division to try and figure out what this gives us after we do synthetic division. So I just write down my 3 because we're told 3 is a 0 of this polynomial. So when I do all this, I'm going to be left with remainder 0, and then I'm just going to be left with what's left. So I write down my coefficients: 2, -3, -11, and 6. I don't know why I do it at +6. I apologize, but kind of too late to erase now. It's a good thing that this lecture is almost over because this pen is not wanting to behave for some reason. But anyway, I move down to 2. Okay, well, let me finish. Probably not. But that's a 2 times 3, which gives me 6. I just write with my hand. Yeah, I'm just writing with my hand. So it's a 6. That gives us 3. Okay, 3 times 3 is 9. -11 plus 9. That's going to give us -2. Okay, and so -2 times -6 is, well, times 3 is -6, which gives us 0. Okay, so what does that leave us? Okay, that leaves us with the polynomial 2x squared plus 3x minus 2. All right, so that's what the factor theorem tells us. Okay, and yeah, that's it. That's the end of my presentation, everyone. Nice 30 minutes. If you have any questions, don't hesitate to email me. But as of now, that is your lecture for Friday. You all have a good day, and I will see you all when I get back.